Okay, welcome to the online lecture on differential equation. The topic is variation of parameters. In last two lectures, we discussed the variation of parameters, uh, the existence of variation of parameters, and the problems including that means problems using variation of parameters. Today, we will discuss some more problems on variation of parameters. Okay. Uh, that is first one. See here, y double dash plus 3y dash plus 2y is equal to 12 into e power x. Actually, this problem you can do in another way also, like q is equal to e power ax form. Now we are doing this problem in variation of parameters also. Now I am writing this one y double dash as d square. That means here I am writing d is equal to capital D is equal to d by dx. Then y double dash will be d square, y dash will be d. So the problem I am rewriting it as d square plus 3d plus 2 into y is equal to 12 e power x. Here r of x is equal to 12 e power x, which is used to find a and b values. Now auxiliary equation, just replacing m instead of d. This is m square plus 3m plus 2 is equal to 0. Now if you factorize this equation, it becomes m square plus 2m plus m plus 2 equal to 0. That is 2 into m square is 2m square. Now we have to write 3m as sum of two terms, which sum is 3m and which product is 2m square. Now that the one possibility is m square plus 2m plus m plus 2 equal to 0. If you take m common in first two terms, it becomes m plus 2. Again, if I take 1 here, m plus 2 equal to 0. It becomes m plus 1 into m plus 2 is equal to 0, where we get m values as minus 1 and minus 2. Here, the values are real and distinct. So, yc will be c1 e power minus x plus c2 e power minus 2x. Now, in the variation of parameters, what is the procedure means? We have to assume one value is u and another value is v. So I am assuming u of x is equal to e power minus x, v of x is equal to e power minus 2x. It is not necessary to take the first value as u of x. It's your choice. Even though if you take u of x is equal to e power minus 2x, the answer will be the same. So yp. Now we are assuming yp as a into u of x plus b into v of x. Now to find ab values, we need this value u into dv by dx minus du by dx into v. We assumed it, not assumed, this value actually equal to Wronskian of u and v. So the value is e power minus x, dv by dx is minus 2 e power minus 2x and du by dx is minus e power minus x, as u is e power minus x, v is e power minus 2. If you simplify this one, e minus e power minus 3x, which is not equal to 0. Okay. By variation of parameters, first we are finding a value. Our final aim is to find a and b value. So now we are finding the a value. A is equal to the formula is minus integration Vr by WuV. In previous problem I have written instead of WuV I have written, that is Wronskian of u comma v. Instead of this one I have written u dv by dx minus du by dx into v. But now I am writing it as w of u comma v. Okay. Now v is e power minus 2x. R is, in the problem it has given 12 into e power x. W of u comma v, just now we have found, minus e power minus 3x. All the values are in e only. So in numerator this value is e power minus x. If you bring e power minus 3x to the numerator, it becomes e power 4x. That is e power 4x, e power minus 2x becomes e power 2x. And 12 here I am taking outside, and the integration of e power 2x becomes a is equal to 12 into e power 2x by 2 that is 6 into e power 2x. Now the b value, b is equal to integration ur by Wronskian of u comma v. That is, u is e power minus x, r is 12 e power x by minus e power minus 3x. So here also, if you simplify, this value becomes minus 12 e power 3x dx. That is equal to minus 12 e power 3x by 3. The total value becomes e power minus 4 into e power 3x. So the general solution becomes y is equal to yc plus yp. Y is equal to yc, what we have written, c1 e power minus x, c2 e power minus 2x. And what is yp? A into u, b into v. This is a, what we got by the simplification. 6 into e power 2x into e power minus. B is minus 4 into e power 3x into v, e power minus 2x. If you simplify, you will get the value as 2 into e power x, this total value. Okay. Here I have mentioned by initial method. That means in the previous units, we also find how to find yp for 12 e power x. That is 1 by d square plus 3d plus 2. Whenever q is equal to e power ax, we have to substitute d is equal to a if and only if. That means when it is not equal to 0. Here if you substitute 1 instead of d, it won't be 0. 12 e power x by 1 square plus 3 plus 2. So the value becomes 12 by 6 e power x, that is 2 e power x, which is same as 2 e power x. Okay. That means even though if you do by variation of parameters or any other method, the value is same. But the importance of variation of parameters, some problems we can't do by the just formula based. So those problems, that is q is equal to secant x, cosec x, sin e power minus x. Those problems it is not possible to do by the previous units. Okay. Now those problems also you can do here by using variation of parameters. Okay. Now the last one I'm going to explain. See, here it is e power minus x log x, r of x is equal. This type of problems it's not possible to do by previous units, what we learnt in previous units. Now by this one we can do easily. See here, y double dash 2y dash plus y. I'm writing it as d square plus 2d plus 1 into y. Here d is equal to dy by dx. D is equal to d by dx. R of x is equal to e power minus x log x as it is. Auxiliary equation, see, it becomes, instead of d we have to write m square plus 2m plus 1 is equal to 0. It becomes m plus 1 whole square equal to 0. M is equal to minus 1 minus 1. Repeating twice. So here to write the complementary function yc, the roots are minus real and repeated. So the solution will be c1 plus x c2 e power minus x. That is c1 e power minus x plus c2 x e power minus x. Okay. So u of x will be e power minus x, v of x will be x into e power minus x. So yp will be a into u of x plus b into v of x. Now we are finding Wronskian of u comma v value, which is useful for finding a and b values both. So w of u comma will be u into dv by dx minus du by dx into v. So e will be e power minus x, v will be x into e power minus by again product rule for differentiation, minus du by dx minus e power minus x, v x into e power minus x. So if you simplify, you will get the value e power minus 2x. So a is equal to minus integration Vr by Wronskian of u comma v dx is equal to minus v x into e power minus x, or which is given in the problem e power minus x log x. Wronskian w of u comma v, you can write e power minus 2. In the numerator e power minus x, which becomes e power minus 2x. So I have cancelled here, and it is minus integration x into log x. So integration minus log x. Now here I am applying integration by parts formula directly without already I have given modified integration by parts formula. Don't apply here. Why? Because if you apply here, we are not able to find log x value directly. So I am applying here integration by parts formula. I have used here by integration by parts also. X into log x. First log x I am taking first function. X is x square by 2 minus integration log x differentiation is 1 by x and x square by 2 as it is. Here x gets cancelled and in the integration x value left and the integration of x will be x square by 2. Here 1 2 is there. I can minus of minus will be plus x square by 4. This is our e value. Next, b value. B is equal to ur by Wronskian of u comma v dx. U is e power minus x, r is e power minus x log x by Wronskian of u comma v will be e power minus 2x. So here e power minus x, it becomes e power minus 2x. So both are get cancelled and log x. Directly also we can write the log x integration, but I have derived also. Log x I have written log x into 1. So first log x and integration of 1 is x minus log x differentiation is 1 by x. Integration of 1 is x. So x gets cancelled. X log x, here integration dx, that becomes x. So the general solution will be y is equal to yc plus yp. c1 e power minus x, c2 x e power minus x. This is our yc. Yp will be a into u plus b into v. Now if you simplify, it becomes e power c1 e power minus x, c2 e power minus x plus e power minus x into this value. Okay. Now that's enough for variation of parameters. Once again, I am recalling what we learnt in variation of parameters. First, we derived the formula for variation of parameter. That means the procedure, how to do. The suppose one second order differential equation is given and asking to find the general solution by using variation of parameters. Then we derived that first we have to find the yc value. Then yp value is equal to au plus bv, and we derived the formulas for a and u. Then at last y will be yc plus yp. Okay, and we jump to the next method, that is reduction of order method. What is the reduction of order? In the name itself it says we are reducing the order. Okay, in the reduction of order method, in the problems they give one solution, we have to find the another one by using the given one. Okay, here in the variation of parameters the coefficients were constants, but in the reduction of order method the coefficients may not be constants. Here it may be the functions of x. Okay, see the reduction of today, we just derived the formula for reduction of order, and in the next class we'll do some problems related to reduction of order. So reduction of order, the differential equation is in the form of f2 of x d square y by dx square plus f1 of x dy by dx plus f0 of x into y is equal to q of x. Here the coefficients f2, f1, f0, q of x are functions of x. Now we are considering the homogeneous equation of this one. That means q of x equals 0 if we take, then it becomes y2 f2 of x y double dash of f1 into y dash plus f0 into y equals. Here y dash means y double dash means d square y by dx square. That's it. So in the problem, yeah, they are giving if one non-trivial trivial means 0 by base, means here we assume 0 is also solution, but we are not considering 0 here. So one non-trivial other than 0 solution is given. We can find second linear independent equation y2 to equation 2. That means we are finding solution to the homogeneous differential equation here, not for the original one. Okay, original one means this one is equal to q of x, not for this one. We can also find a solution for this one in another way. Those type of problems also we discuss here. So y2, what we are assuming y2 is equal to y1x into integration of u of x dx. Here what are the known functions to us? Y1x is known, we don't know the u of x, and y2 will be integration of u of x. So first we find the u of x, then automatically integration of u of x easily we can find. Here see, y2 of x is also linear independent solution. That means y2 of x also satisfies this equation. So y2 of x satisfies this equation means we have to find y2 double dash, y2 dash, y already given. So we find all these values and we substitute in equation 2. Then we'll get the integration u of x value. Okay. So y2 dash of x, that is y1 of x. This is second function, product function, derivative of this one, and derivative and integration is there. Both are inverse functions. So y1 into u plus y1 differentiation will be y1 dash. Y1 dash means differentiation of y1 into integration u of x dx. Again I am finding second derivative y2 double dash. It will come y1 u differentiation is u dash plus y1 dash into u plus here y1 dash, again differentiation of this integration function will be u plus y1 double dash integration u of x dx. All these values we are substituting into. Then if I take common integration u of x dx, this value will get plus y2 y dash u dash plus 2y2 y1 dash plus y1 y dash into u equals. Here what we are taking means we are taking y1 is solution to the homogeneous equation. That means it has in the problem itself they given. That means y1 value satisfies this equation. If you substitute y1 here, it becomes 0. So by using that purpose, see, as y1 is a solution to 2, this total value becomes 0. That means this total value becomes 0. So 0 plus the same value I have written here. Our aim is to find the u value. Okay. So multiplying the above equation with dx by u into f2 y1. Okay. See, for each, here we have 3 terms. By each term I am multiplying this one. I skip dx here. At the time of integration we will write. So f2 y1 u dash by u f2 y1 plus this value by the u y2 f1 and the last value by u y2, sorry, f2 y1. Okay. So here u dash means du. I am writing leftover terms here, u dash by u 2. Here what is that? D y1 dash, derivative of y1 dash term by y1. Now I am writing this last term right side minus f1 of x by f2 of x dx. So if I integrate this one, integration du by u plus 2 dy dash by y dash, sorry, dy y1 dash by y1 is equal to minus integration f1 by f2 dx. See here it is du by u means log u plus here dy dash dy y1 dash by y1 means log y1 dash, 2 is here, minus integration this value we don't know, directly writing as it is. So here it is in the form of log a plus log b. If I 2 here, if that means power to the y1 dash, it becomes log u into y1 square is equal to this value. So u into y1 square value will be exponential e power minus integration f1 of x by f2 of x dx. But we have to find the u value. U is equal to e power minus f1 of x by f2 of x by y1 square. So y2 will be y1 into integration dx. Then the yc will be yc is equal to c1 y1 plus c2 y2 is a solution to our homogeneous differential equation. So Now we derived the formula for reduction of differential equation. Okay, in the tomorrow's class, in the next class, we'll do some problems related to reduction of the order. So in the today's class, we finished the variation of parameters, and notes will be shared to you by the Google Learning app, and some exercises also will be given to you. You have to solve them, and you have to send the copy of those solutions to. Okay, that's all for today, and stay at home and stay safe. Don't go anywhere. All the video lectures will be provided to you. Okay, thank you.